Hello guys, welcome back to my YouTube channel. My name is Dr. Sammy. Today we'll continue with the second episode of um the 14 days calculations to Jamb. Now all the questions I'll be solving under this topic, which is Newtonian and momentum calculations, will be picked up from what Jamb questions, because Jamb is concerned about your in-depth knowledge on each topic you are being presented to study. So therefore, we're diving into the question straight. But before diving in, I want you to do something for me. Please kindly would encourage and support my channel by what subscribing to it, and then like, and then drop your feelings or how you felt about the video. If the video was impactful, drop any remark you have in the comment section below. So drop the remark you have in the comment section below. Thank you. Now let's dive in um into the big deal of the day. So a machine gun with a mass of 5 kilogram. So solution, first thing to do is to write out my parameters. So the mass of the machine gun, mg, which is mass of gun. So therefore it is what, 5 kg. Fires the bullet 50-gram bullet at a speed of 100 meter per second. So the mass of the bullet, which I will call mb, is what, 50 gram. Now to convert from gram to kilogram, I have to divide it by 1000. So dividing 50 by 1000, I think I will have 0.05 kilogram. Now I've done justice to that. At a speed of, so the bullet velocity of bullet, that's 100 meter per second. Now therefore the recoil speed of the machine gun is, so now we are asked to look for the what, velocity of the machine gun. A solution, now the formula to use when you hear recoil and when there is comparison between mass of gun, its bullet, its velocity of the gun, and the distance, and the velocity of the bullet. When you are given these four parameters, the formula to use is simply mg vg. That is, the momentum of the gun is directly proportional to the what, momentum of the bullet, which is mb and vb. Now therefore let's substitute what we are given so that we'll get our answer. So mg is what, 5 times vg is what, we don't know, and that's what we are looking for. Therefore times mb is what, 0.05 times vb, 100. Now dividing both sides by 5 to get our answer, and we'll have vg to be multiplying and solving this, we'll have vg to be what, 1 meter per second, which make our answer to be what, option C. Now welcome back to the case 2 question. A rocket burns 0.01 kg of fuel, so therefore the mass of fuel burnt is 0.01 kg each seconds, and eject it as a gas with a velocity v. What force does the gas exert on the rocket, F? So therefore you are being simply asked what force does the what, gas exert on the what, rocket, and therefore together the formula is using the force exerted is caused by the product of the mass and the velocity of the what, of the of the of the mass and velocity of the what, of the rocket. So therefore the rate at which the rocket moves is directly proportional to the what, force imparted on it. So that is why F equals to what, mv. Therefore F equals to mass 0.01 times velocity 5000. Therefore my F is now equal to, doing this we'll have 50 Newton. So therefore my right option is option C. So now this case 3 study of what, calculations under Newtonian of force and then momentum. A force of 16 Newton applied to a 4 kg block. I told you the first thing to do is to write out your parameters for a force of 16 Newton. So F is 16 Newton, the mass is 4 kg, and the block, when an object is at rest, it means the initial velocity is what, is 0. So on the smooth surface, what is the velocity? And we ask for velocity, and then the time is 5 seconds. So now working with these parameters, we know our F equals to ma. And recall your A is V minus U over T. So we can say F equals to M. Anywhere you see A, put this value, it becomes V minus U over T. Therefore, we can use this to solve. My F is what? 16. My M is what? 4. And then V minus 0, because U is 0, then I'll be left with only V here over T. What was my T? My T is 5. 5. So I can cross multiply now. By cross multiply, I have 16 times 5, which is what? 80, equals to 4 times V, 4V, which is 4V times 1 is still 4V. So 80 equals to 4V. Dividing both sides by 4, I believe I'll get my answer to be V equals to, I think, 20. So therefore, 20 meters per second. Let's check if our answer is in option. Okay, option C. Now, let's focus on the case 4 question. Solution. A gun of mass 2 kg. So the mass of the gun is mg and it is 2 kg. Fires a bullet of mass. Now the mass of the bullet is 1.6 times 10 raised power minus 2 kg. If the bullet leaves the nozzle of the gun with a velocity, so the velocity of the bullet is 150 meter per second. What is the required velocity of the gun? So velocity of the gun is what? Question mark. So now, since these questions fall under recoil of gun, I've told you that the formula is mg vg equals to mb vb. So therefore, using this formula, the mass is what? 2 times, we don't know the velocity of the gun. The mass of the bullet is 1.6 times 10 raised power minus 2 times velocity of the bullet is 150. Now we will have 2 vg equals to 1.6 times 150. Now we have 240 times 10 raised power minus 2. Divide both sides by 2. Therefore, our Vg becomes 240 divided by 2 will be this 120 times 10 raised power minus 2. Now, changing this to standard form, 120 to standard form, we have 1, 2. So therefore, it will be Vg equals to 1.2 times 10. How many times do we move positively? 2. So I'll put 2 times 10 raised power minus 2. So 10 raised power 2 and 10 minus 2. We can have 1.2 times 10. According to indices, you pick one base and add the power. Adding the power is 0. So therefore, 1.2 times 10 raised power 0 is 1. So therefore, the velocity of the gun is 1.2 meter per second. But now look at the option. They are testing your knowledge. How far or how much do you understand question under what? Under requirement of a gun. So therefore, do you notice something? When you shoot a gun, you feel what? A backward force, like you move backward, even though the gun is the bullet will be moving forward. The gun will what? Eject you backward. So therefore, if somebody shoot a gun eastward, the ejection will be what? It will be westward. So therefore, the velocity of the gun will eject back. It will move you back. So the velocity of the gun will be what? East. It will be what? The opposite of east, which is what? West. So the ejection is what? West. So therefore, when we are picking an answer to be 1.2 meter per second due west. Now, guys, moving down to case 5, study under Newtonian calculation and momentum. We have this question as a case study. A 0.05 kilogram bullet. So the mass of the bullet is 0.05 kilogram. At 500 meters per second horizontally, strikes a thick vertical wall. So the velocity, let's say the velocity u is 500 meters per second. Horizontally strike a thick vertical wall. It stops. So the velocity, since the since the object stops, so it will come to rest, so v equals to 0. After penetrating through the wall, a horizontal distance, so our s is 0.25 meter. What is the magnitude of force? F is unknown. So, but for us to get the magnitude of force, we have to know what our A is, so that we can use F equals to ma to get our force of impact. So, for us to do that, we need to look for our what? Acceleration, then solution. Then you should recall that there is a formula that connects acceleration with these parameters given above. This is the formula. It is one of the formula of what? Uniform velocity on a straight line. So v square, our v is 0 square equals to u square. Our u is 500 square plus 2 times a times the distance is 0.25. So working with this, I think we have this 0 equals to 500 square. 500 square is 250,000. 250,000 plus 2 times 0.25 will have 0.5a. So collecting like terms, I think we'll have equals to 0.5a. So I'm bringing this value here so I can get the value of a. So dividing both sides by 0.5 will get the value of a. Therefore my a, this cancel this, my a become 250,000 divided by 0.5, which is now my a is minus 50, so minus 500,000 meter per second square. So it shows that the acceleration of is what is retarding, that is bringing the object to what, to rest. So now let's calculate our force. F equals to what? Ma. So now it's just the negative does not mean anything, it just means the acceleration is retardation. So therefore my mass is now what? Mass is 0.05 times 500,000. Now because the negative just means retardation, that's why I'm not putting it. It does not mean anything. It shows what is happening to the acceleration. Therefore my F equals to times 0.05, which is 25,000 Newton. So is this okay? Yeah, our correct option is option E. So now guys, this is the case C study of calculation under this topic. Now before we proceed, ensure you don't forget to subscribe. Don't just only gain from this channel, but ensure you support the growth of this channel so that we'll keep making useful videos like this. Ensure you contribute and you also make an impact back to the channel. Thank you so much. I love you. Now continue. For us to continue solving these questions, I need to write down the word parameters. That is what I'm giving. Now, a 1,000 kilogram elevator is descending. Now, when you hear the word elevator, there is a formula you need to know. I'll write down the formula, but let me write out the parameters first. So the mass is 1,000 kg with acceleration is 1 meter per second square, and the acceleration due to gravity is 10.0 meter per second square. I'm asked to look for the force. Now whenever you are presented with a question whereby you see elevator and then you add that the elevator is descending, the formula you are going to use is this: F equals to mg minus ma. But if the elevator is ascending, this negative sign will turn to positive. But because it's descending, that is why the sign is what? Negative. So if it is ascending, the sign will be positive. If it is descending, it will be negative. So this is descending, therefore the sign is what? Negative. So to calculate the tension, which is also force, is mass times gravity, which is 1,000 times 10 minus 1,000 times 1. Then we have 10,000 here minus 1,000, which makes 10,000 minus 1,000 is 9,000 Newton. So therefore my answer is option C. Now guys, we have this case 7 question. Solution. I need to write down my parameters. A 5 kg block, so the mass of the block is 5 kg, is released from rest on a smooth inclined plane at an angle. So the angle is 30 degree to the horizontal. What is the acceleration down the plane? A. Now we need to know the force acting on this plane. To understand this carefully, you need to check my video on friction and force on what? On inclined plane. I'll drop the descriptions. I'll drop the link in my description below. So so you need to know the word force acting along the word inclined plane, and then the force acting along the inclined plane is F equals to mg sine theta. So we need to know the force acting along the word inclined plane. So, and you also know that the relation force is what? Ma. Force, recall force is ma. So I can say this force, let it be what? Ma. So ma equals to mg sine theta. Therefore, further solving, I can divide both sides by mass, which is m, divide this side by m, and have m cancel m. So my a is now g sine theta. So therefore, a, the acceleration is now g. What is g? G is what? 10. That is, the acceleration due to gravity is always constant, 10. Sine theta is what? 30. So taking this, 10 sine 30 will have what? 5. So therefore, 5 meter per second square. And then my option is option A. Now looking at this question carefully, case 9, a ball of mass. Now before solving this question, what you are asked to look for is the impulse. And know that impulse is same thing with change in what? Momentum. So therefore, but let me write the parameters out. Mass 0.15 kg, and then kicked against a rigid vertical wall with a horizontal velocity of this, if it rebounds with a horizontal velocity of 30 meters per second. So therefore, my velocity is 50 meters per second, and then my initial velocity is 30 meters per second. I'm asked to calculate the what? The impulse of the ball on the wall. Now, impulse is simply change in what? Momentum. And change in momentum change in momentum is mv minus mu. Are we together? That's the formula for change in momentum. So therefore, change in momentum equals to factorizing m out, it will have v minus u. And I say that impulse is same thing with change in momentum. And then see how impulse is f equals to, let's say f equals to, acceleration is v minus u over t. So cross multiplying, we will have what? Impulse, which is ft equals to mv minus u. If you cross multiply, f times t is this, and this times 1 is still this. So can't you see the same thing with what? Momentum. So I can say that ft equals to what? Mv minus u. That's impulse. Now my ft equals to, the mass is 0.15, and difference between the two velocity, 50 minus 30 is 20. So my impulse therefore my impulse, which is ft, can now be, my impulse can now be 3. Now the unit is Newton seconds. Ft, Newton seconds. So my impulse can now be option A. Now under this case 10, a body of mass 12 kg. Now this question is under collision. Okay, but let me write down the parameters, and I'll give you formula for collision when one body is at rest. When a two bodies colliding and the first body is in motion, the second body is at rest, I'll give you the formula. A body of mass 12 kg, traveling with what? At 4.2 meter per second, collide with the second body of mass. So it's traveling with this 4.2 meter per second. So m1, m2, the mass is 18 kg, and the body is at what? Is at rest. We're asked to calculate the common velocity, which is v. Now when one body is at rest, two bodies are colliding and one body is at rest, the formula becomes, for collision, it is m1 u1 equals to m1 u1 equals to m1 plus m2 v. Please take note of this formula carefully. But when two bodies are colliding and their velocity is not at rest, then we have the formula is to be m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So when the two bodies is not at what is not at rest and they are colliding, the formula is this. But when the two body out of the two body, if one body is at rest, the formula is like this. So therefore my first mass is 12 times first velocity, which is u1, is 4.2 equals to 12 plus 18, which is m1 plus m2, and we're asked to look for the common velocity. So 12 times 4.2 is 50.4 equals to 12 plus 18. 12 plus 18 is 30. So we have 30v here. Divide both sides by 30. So therefore we have v to be 50.4 divided by 30. My answer is 1.7 meter per second. And I think our right option is option D. Now guys, case 8 question. Now I need to write out my parameters. But before writing my parameters, an elevator of mass 4,800 kg is supported by a cable which can safely withstand a maximum tension of 60,000 Newton. So the first thing I need to do is that you should know that the mass of the elevator is acting downward, and this tension is just like a spring hanging it, so it's acting upward. So I need to calculate my net force from these two. So therefore my F net will become this weight, which is this, which will be this weight. This weight, you take it away from this one. So to calculate my F net, so this is 60,000 minus. Now this is just mass, so I need to calculate the weight. So the weight should be mass times gravity. So for 4,800 times 10, it will be what? 48,000. So therefore my F net is now, that is what is giving the acceleration, 6,000 minus 48,000 is now what? 12,000. Yeah, it's now 12,000 Newton. So therefore now I can now calculate my what? My acceleration. So therefore we are looking for our acceleration, and the mass is just 4,800 kilogram. So therefore my F equals to ma, and then my force is 12,000 equals to the mass is 4,800 times a. So dividing both sides by 4,800, divide this side by 4,800, and I have my acceleration to be 2.5 meter per second square, which is option A.